Yes, today we are going to start the second part of vectors. Last week we finished at, or last day class is concerned, we finished at vector addition. Today I am going to explain that again, certain parts, and continue with vector deductions, that is subtraction, and the other theory related to that. Okay, we'll go ahead. Now, to add the vectors, always we have to use the vector triangle theorem. A, B, C. Last week, it is a continuation of the last one, part 1. So then, this is AC. The vector AB plus vector AC is equal to vector BC is equal to vector AC. Normally, remember, the theory can be extended. These two are the same. Then if you forget about these two, you get AC. When you want to add more, that means vectors by, we'll say there are 3 vectors. AB, another vector BC, another vector CD. You can understand in 2 ways. When you add these two, AB plus BC, AC is the addition. Now you have to add AC plus AD. Then you get this one. First you have to add, considering triangle ABC, the triangle ABC, and get AC is equal to AB plus BC. Then AD, AC plus CD. Next one, AC plus CD. That means these two are the same, therefore answer is AD. From the triangle also you can see AC, CD, then AD is the answer. For this addition, 2 arrowheads are drawn here, 3 are drawn by me here. AC is equal to AB plus AC. So then AB plus BC plus CD is equal to AD. Right, note it down. Like when we want to get more than, when you want to get the addition of more than two vectors, then we can use this method extended way. But always not needed to get the diagram and do it. Not needed all the time. For instance, we'll say they are asking you to add AB plus CD, two vectors, plus BC. Then after that, 2 times DA, get the addition of this. What you have to do is, now you fail to draw the diagram and do. There is no need to draw the diagram. You can do like this. You can arrange this. Normally, if same letters are closer to each other, we can add easily. Then AB plus BC. This is taken here. Then plus CD plus 2DA I am writing as DA plus DA. DA plus DA is 2D. A. Now what you do is, here you can add these two together easily. So that means you can use it. These two are same. These two are same. So therefore, AB plus AC is, AB plus BC is AC. You drop B. Then CD plus DA is CA plus DA. Now, here you get C and C. Then you get AA. I had to explain it later. AA means same point from A to A. Then it is C. A to A is same. Plus DA. Therefore, this is 0 plus DA. The answer is DA. Diagram is not always needed. You can do in that way. Go ahead. In this way, we can continue or we can extend this for the other vectors also. So therefore, we are getting sometimes with the pictures also they are giving. Before that, I'll give you some definitions now. Right. Next definition. Null vector. Null. Null vector. Null vector means the magnitude of the vector is zero. Then right? When the magnitude of a vector is zero, when the magnitude of the vector is zero, that is called null vector. Null means nothing. Null means nothing. So then null vector is denoted by C, that is null vector. Next one, that means null vector is denoted by a dot. Then write null vector is denoted by a point, and we consider the magnitude of the point is zero. Since a point is denoted by an English capital letter normally, when we write the vector, we write it as AA and it's zero. If the point is B, BB, vector is zero. Then we'll come to next one, unit vector. Unit vector. Unit means one. And it is called unit vector. When the magnitude means the value. Magnitude of a vector is 1, then it is called unit vector. Magnitude of a vector is concerned. We'll say vector is simply the magnitude of the vector is denoted by drawing two parallel lines like that. Then it is called modulus. For unit vector, A is equal to 1. That means A is a unit vector. When it is unit vector, when you put two parallel or when we write in between two parallel lines, that is modulus. Modulus means value. Value is 1. So therefore, value of A is 1 means A is a unit vector. A is a unit vector. When A is a, when we'll say B is a null vector, then modulus of B, that means the value is 0. No vector sign here, the value. Two lines are drawn, it is called modulus. Modulus means magnitude. Magnitude is 0. That's for null vector. We'll do another example. There you get addition of vectors. Again, A, B, C, D, D, Z, B, C, plus Z, D. Then right? At the given vectors. At the given vectors. Then write this one. That is a question. Then the answer is, you have to rewrite this. After that, we have to arrange this. Is equal to AB. Then B is there. When next one is starting with B, then it is easy to add. Then when it is CD plus DZ, DZ plus ZD. Always count number of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If you drop one, you don't get the answer. These two are equal. These two are equal. So therefore, AB plus BC is AC. CD plus DZ is CZ plus ZD. These two can be added. Then you get AZ plus ZD, remaining one. These two are added, you get AA. AA means 0. Addition, it's equal to vector, null vector. Right, go ahead with that. quickly do. We'll do another question. Before that, I'll tell you another one. That is, in mechanics, you get resultant. Resultant means even for forces, then resultant force. For velocity, resultant velocity. Speed, resultant speed. Resultant means the single one equivalent to certain vectors. But vectors are concerned, we'll say force. Force has a direction, force has a magnitude. So you can add them, and the final answer is called resultant. Then write it. When several forces are added together, within brackets you write 2 or more than 2, the single force equivalent to that is called resultant. That is called resultant vector. Resultant vector. So then resultant means when you add, but when it is a force, resultant force. When we are adding velocity, resultant velocity. Those are explained under mechanics. But resultant word is equivalent single vector. So then normally for the questions are concerned, they will be given sometimes with the diagram. For example, we'll consider Note down. Four forces acting on an object are given by vectors of OA, BC and CD. BC, and CD. The diagram shows the values. Diagram shows the values. Here it is B, here it is A, here it is O, then here you get D. O, A, B, C, D. And the values given as the vector values forces 7P, 5P, direction is drawn with the arrowhead, 10P, and 6P. Find the resultant force. Now, without this also we can find. Remember, when you are trying to find the resultant, always the direction should find and magnitude. So we'll start with this. The vector OA plus vector AB. These two are together. Then we get OB. Correct? No? Triangle is concerned when you get OB. Resultant of these two is equal to this. Right? Then we can find this. Again we can add these two. Then you get another one. But we know resultant is equal to directly. Resultant is R is equal to OA plus AB, vector addition, BC plus CD. Without finding like this, altogether we can add. We know that it is easy to add when same letters are there. Then this is OB, this is BD. Again these two are the same. Then OD. Then OD is the value. Now you have a small issue there. The diagram should be don't draw as shown like then. So diagram is given like this. Dotted line is here. Starting point is here. Like this it is given. This is O, this is D. Then our answer is OD. This is a rectangle. So therefore the front, this is a rectangle. Then write OA, BC, BD is a rectangle. So therefore OD is equal to AB value. So then OD is equal to AB, AB is equal to 5P. Then O to D is this direction. Then the answer of the resultant is 5P magnitude, 5P. Direction O to D, OD. or we can say O to D. Then the resultant answer can be written as resultant is 5P the towards or from O to D. You understood? Geometries used to be used when you find the answer. These dotted lines or broken lines are given. So therefore, this is 90, this is 90, those are given in the question. Therefore, we can say opposite sides are equal. Therefore, OD is equal to AB, AB is 5P. The value is 5P. Value is 5P. Next, most probably today, uh, I don't think, not today. So then, after this class, we are going to start mechanics unit 2. When you want to get the recording, send me a WhatsApp message or double check after 2 days my YouTube. That's a different new channel, not the old one. So there we are going to put as these things because the syllabus is they are going to change now. So therefore I open new page for that. Is a certain part. Normally tubes will be sent from when we start mechanics. Even for this, I will send the tube through WhatsApp. You know, come with the torch. Yeah, bring a torch. Come because I want to find the file. Certain words you have to understand. After this, I'll explain. Those were words related to forces and vectors. Now you consider forces or vectors or any kind of vectors which are on the same plane. So you can understand at once. We'll say this is a force. This is another force. When they are acting like that, this is in one plane, one surface, one plane. But this vector is different direction, then we can't say then all are in the same plane. This is on another way. The vectors or forces on the same plane is called coplanar. Coplanar. Then write next one, coplanar, coplanar vectors. Coplanar vectors means those vectors are on the same plane. Then write when several vectors are concerned, or if the all vectors are in the same plane, then it is called coplanar vectors. Coplanar planar vectors. So that means we'll say AB vector CD vector EF all are on the board. Then write. Now consider vector AB, CD and EF are on the plane of the board. Then these vectors are coplanar vectors. Vectors. അത് 1 to 6 year എനിക്ക് എത്തി. Another example, when several forces are in the same plane, that is called coplanar forces. F1, F2, F3, all are drawn on the board. Then 1, F3 are drawn on the board. That means they are in the same plane. Therefore, we call it coplanar forces. Co means same. When you are getting the forces or vectors all are in the same plane, those are coplanar forces or coplanar vectors. Next example. AB, example, you note it down. AB, BC, comma BC, comma DC, comma ED, comma EF and FA. FA are 6 coplanar vectors. And it is given by the diagram below. Arrowheads you have to draw it according to the diagram. They are asking you to find the, but remember, note down, even the diagram is given, you can add without the diagram. Then write, even the diagram is given, the vectors can be added using normal triangle rule. We'll do and see. I'll write the vectors here again. AB plus BC plus DC. This is the answer. DC, ED, EF plus FA. 1, 2, 3, 4, 5, 6, always count. Otherwise, you don't get. If you miss one, there will be a problem. Now, these two can be added. Then AB plus BC, AC. These two are equal. I drop the letter, then AC. Triangle theorem. Then plus DC. I'll get ED first and I'll get DC there. Then you might ask why. The reason is, if I take, you can place it in that row anywhere. But you can't change the letters. Instead of ED, you can't write DE. ED can be written here, DC can be written there. DC plus EA. Then see why I did it. Now D and D is common. It is visible. Then your answer is AC plus EC. Right? D and D common. I dropped it. EC plus EA. Now I'll take this EA here. EA plus AC. Then I can take A together. Plus C. Check it how I'm doing. Then the answer is EC plus CE. These two are the same. Then you get EE. Same letter is there. Answer is 0. Null vector. If you can't understand, drop me a message. If you want, I'll explain it again. This type of changes are called reordering. So EA is taken to near AC. Then we can make A in the middle like this. Then easy to get the vector addition. Right, next one. If you miss it, you can get it from the recording. You can stop the recording and write the answer. Now I'll give another. The following diagram shows a system of vectors geographically. Find the resultant of those vectors. After that, you have to draw the diagram. A, B, C. Arrowheads are in that way. Then A, C. Then C, D, D, E, C, D, D, E, and E, A. Those are the vectors. Yes, first draw it. Then I'll do the question. Then vector addition, there is no need to use the diagram as I told earlier. What you have to do is you have to write the correct vector. And correct vector means you have to consider the direction A to B. So therefore, I'll consider first one as vector AB taken. Better to tick BC plus BC taken. Plus C. These are written according to the arrow. Arrowhead goes from D to E. Therefore D. And count, there are 5, but I did not write this. Plus AC. Now we want to get the resultant means you have to add together. These two can be, these two can be, these two can be added together. AB, you have to drop B, then AC. Here you have to drop D, then you get C. Here you can drop A, then you get EC. EC. After that, these two can be added, then you get AE. C is dropped, plus EC. Now these two are the same, then I can drop E, then AC. The resultant is AC. Right. Next question. There are nine vectors GB, GB, comma BD, comma GD, DA, comma DA, AE, EC, EC, DE, DE, CF and EF, comma CF and EF. Those are given by the following diagram. Given by the following diagram. Now I'll draw the diagram. So when you are drawing, it's a triangle like that. Look at this, how to draw. And it is labeled as A, B, C, and the mid points are D and E. This is D, this is E, E. And from these perpendiculars are drawn downwards. And those two are E and F, G and F, G and F. This is also perpendicular. And these two points are connected. D is parallel to this one. Then the vectors are drawn like this. The other one is drawn from starting from here, 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 and here. Here, no, nothing is drawn. 9 vectors you can see, no? 3 here, 4, 5, 6, 7, 8, 9. We had to find them. Actually, you feel to use the diagram, no need. Just write it and get it. Here, look at this answer. GB plus BD plus GD plus DA plus AE plus EC plus DE plus CF plus EF. Then count 1, 2, 3, 4, 5, 6, 7, 8, 9. If you miss, then you don't get the answer. These two are the same. These two are the same. These two are the same. And that's all. Then we can say B can be dropped, GD. These two are added, GA. Then AC. Then we'll write CF here. Then we will write DE plus EF. All should be there. Now 9 was there, 3 were categorized, then 6 should be there. 1, 2, 3, 4, 5, 6. Then look at these two are the same. These two are the same. Then GD plus GC plus CF plus DF. Then you don't feel that same. No, there. These two are the same. Therefore, we can say GD plus GF plus DF. DF. Now, We will arrange GD plus DF. I'll take DF here, then GF. Here you get GF. D is dropped, GF. Again GF. Then the answer is 2GF. Here don't copy, just check and see how you can get those. Nowadays, these questions are not that much popular because anybody can do, no? Therefore, they don't give. Even they give for MCQs. You can add in a different ways also. But final answer is the same. We'll do and see. I'll erase and redo the question. Any method, yeah. What you are doing is when you are adding two vectors, middle two letters must be the same and you have to drop it. Then you get the answer. Again theory. Parallelogram, parallelogram theorem, parallelogram theorem for vector addition. Or we can say parallelogram theorem for adding two vectors. Now consider two vectors here. Parallelogram should be there. When two vectors simple A and B are to be added, when they are represented by the adjoining sides of a parallelogram, the vector addition of the two vectors A and B is given by the diagonal of the parallelogram which goes to the intersection of the two vectors. There are two diagonals, these intersect here, which goes to that. This is the theorem. This is A, this is B, then this is A plus B. The diagonal must be going through the intercept of the two vectors. Draw it. We can prove this. We'll consider this is O, this is A, this is B, and this is C. So then OA, vector OA is the simple A, vector OC is simple B, the vector. Then vector OB is A plus B. How to prove it? Now we'll consider vector triangle. OAB is a triangle. Therefore, OA, don't write, OA plus AB is equal to OB. Now, when you consider parallelogram, OB is equal to AB. Opposite sides are equal. Opposite sides. Then OB is parallel to AB. Direction, acting direction. O to B is equal to OC is equal to AB. OC is parallel to AB. Then O to C is equal to direction A to B. Therefore, vector OC is equal to vector AB. We proved it in this way in the last class. OC is equal to AB. So therefore, now we'll start with the other part. Then we want to add the two vectors OA plus OC. That means simple A plus B. Then here OC is equal to AB. OA plus AB. Then these two are together. That is equal to now OA AB. So this is equal to OB. OB, that means when two vectors are represented by the two adjacent sides of a parallelogram, then the addition of these two vectors are given by the diagonal which goes through the intersection. There are two diagonals, that's why I see. Right? Given by. If you want, you can add something given by the diagonal which goes through the origin or the intersection, and then say by the magnitude and direction. But that is drawn, magnitude is length, direction is the same direction as it is drawn. Then write up to this. If we ask the direction should be given from OA. This is the angle theta. That is the direction. Normally, day-to-day life, that we can apply this, but with the mechanics, I can tell you a lot of day-to-day life situations. Normally, I tell, but here it's can be told, but those are not that much needed. But the easiest thing is triangular method. But you should know that this also. Most of the diagrams are concerned, there is no need to use the diagram, we can add normal method. The middle letter can be dropped. That means we are applying triangle theorem or this theorem. Okay, now we'll consider about another question. Note down. There are four vectors having values 3, 4, 5, 6. And they act towards north, south, then east and west, respectively. Find the magnitude and direction of the given four vectors. The given four vectors. We want to find the magnitude and the direction. For that, we have to use again the diagram, but no any letters are given. So therefore, we have to draw first. The directions are given according to this respectively. North, that direction we are having 3. Then after that, we are having again downwards. That means for the south, the value is 4. Then we are having towards east 5 and west 6. Those we have to add. When we consider this, we can draw equivalent diagram to this. Because here towards this direction 5 to this direction 6. Then it is the same straight line. We can get the resultant of these two. That means opposite direction, those are to be, first one is 5 here. We'll say O x. Then from x to y, it's 6. You have to come 6 here. Then the resultant is O y. O y is equal to 6 minus 5, 1. So these two can be reduced as 1 towards west. Why? East 5, west 6. West side is greater. The difference is 1. The other one is 3 up, north, 4 south. Then downwards, 4 by 3. 4 minus 3. That is 1. 1 downwards. Here also 1. Then 2 vectors are there. Their values towards west, towards south. Then to add these two, we use the vector addition theorem. A, B, value is 1. Then B to C, value is 1. Then you get the resultant towards this. We reduce or simplified according to the normal theory. Then we are using vector triangle. Normally, AC squared is equal to Pythagoras. AC squared is equal to AB squared plus BX squared. Now, that is C, sorry, C. A, B, B, C squared. Then, these two. AB squared means 1 squared. BC squared means 1 squared. That means 1 plus 1. That is 2. You just get the value. Now AC squared, you can't see I'll write it here. AC squared is 1 squared plus 1 squared. 1 plus 1. That means 2. Then AC is equal to square root of 2. Direction. Here, these two are equal. If this is theta, tan theta is equal to, today I am explaining the trigonometry. Tan theta is equal to opposite divided by adjacent. Opposite is BC divided by AB. BC is 1, AB is 1. Then the answer is 1. Tan theta is 1 means theta is 45. Right? Theta is 45 means when you consider any direction, this is south, this is west, this is 45 means this direction is, what is that? Southwest. In the southwest, it is 45. Then the direction is southwest. Then do it. Those are actually, we can do it as MCQs. That means when you draw that, you can see 5, 6 is here 1 day. 4 is down, here 3 is up. Then 4 minus 3 is the resultant for this. Then downwards 1, here you get 1. From that we know opposite and adjacent sides are equal, it is 45. This is 45. For MCQs you can do in that way, quickly. After coming here, I use Pythagoras theorem. Theta is 45, from there you can see the direction. Now we'll come to another theory, that is subtraction of vectors. Note it down. Subtraction of vectors. Subtraction of vectors. Now subtraction of vectors means you have to deduct, right? We'll say A and B are two vectors. We want to deduct vector B from A. Then we want to find, right? Consider simple A and B are two vectors. And the vector B must be subtracted from A. That is A minus B should be found. Normally negative vector, I said last time, you have to tell the direction or consider direction opposite way, then negative vector comes. That means AB is a normal vector, then BA is negative vector of AB. BA is negative. Note down like this. When AB is a vector, BA is the negative vector of the negative vector of AB. Now, what we do is, then right, instead of deducting B from A, we can add the vector minus B to vector A. That means A minus B is written as vector A plus minus B. Right? Minus B. We'll say vector A is towards that direction, vector B is towards this direction. Then A minus B is equal to A plus minus B. Vector minus B. Then B is given. Minus means you have to change the direction. We'll say it's B starting from here. Then our answer must be now A is here. Then we are having B here. Now we have to add A to minus B. Minus B is opposite direction of B. That means this is minus B. Equal and opposite. If you say OA, OB, magnitude of OA is equal to magnitude of OB. OA is parallel to the OB, same line. Then direction O to A or A to O is equal to O to B. I change the direction. That means normally OA and OB opposite. That means AO and OB is to the same. Therefore, vector OB is equal to minus B. Then we have to add these two. If you consider this as C, BC is the answer. Then we can say CO plus OB, CO plus OB. CO plus OB is equal to CB. CO is A, OB is minus B. Vector C. If you can't understand, tell me. Mechanics is easy. That can be done. Easy means a bit tough, but you can do it. It's very interesting, the first parts. I'll draw A plus B and A minus B on the same diagram. Wait for a while. Anybody sending messages? Send me to WhatsApp. Right. Now, this is concerned main situation is we have to get, don't worry about that much, these things, because I explained because it's in the now new one. Again, I'll show you how to do that. This is A, this is B, then look at this, O, A, B, Then this is A plus B. A plus B. Same amount or same length is to be considered like this and draw this. We prove that then C is, this is minus B. Direction is opposite direction. Same value, same value. Then this is OC is A minus B. This is what we considered. Draw it. Remember, always what we do is we add the negative one. Then you get A minus B. Another example, numerical example. An aeroplane flies 120 kilometers towards east, then 50 kilometers towards north. Find the displacement of the plane. I did some questions, one or two questions last week also, in the last section. First, you have to know about the directions. North, south, east, west. After that, first it goes to east 120, then north towards east 120 kilometers. Then north 50 kilometers. After that, it goes A, B, C. This is AC. We want to find AC. Use the Pythagoras and find. Have you found the value? Normally, direction we have to find. I considered AB. AB is towards east, then north, A and C. Velocity is vector. So two vectors are to be added when it is two velocities are to be added means two vectors are to be added. Then you consider triangle. Then using Pythagoras, AC squared is equal to AB squared plus BC squared. AC squared is 120 squared plus 50 squared. Then you are getting 14420 plus 25 two zeros. When you add these two together, you get 16900. Then this is equal to AC squared is equal to 16900. That means 169 into 00 means 10 to the power 2. 100. 116. 9 is 13 square into 10 square. Then AC is equal to square root of 13 square into 10 square. 13 square root is 13 into 10. So answer is 130 AC kilometers. Direction should be found. This is theta. Tan theta is equal to opposite divided by adjacent. 5 divided by 50 divided by 12. 5 over 12. Theta is equal to tan inverse 5 over 12. We can write like this. Then the direction we can say the displacement of the car is equal to, plane is equal to 130 kilometers from the first point towards an angle of tan inverse 5 over 12 from east towards north. From east towards north. This angle should be written in this way. Or if you know about this, you can divide this and get the decimal value and get the table and find the angle and write. That also works. This is enough. This trigonometry I'll teach you. You can get the recording. That means YouTube. I'm putting this to the YouTube. Then anybody can get the recording. Last one is also I sent. Hereafter, always after 2 days time, see the recording. Recording means I'll put it to the YouTube. Right. These are simple ones. Now, normally for A levels now, they don't give that much of vectors. But in the syllabus it's there, that is the reason I thought. But you should know these things. Vector addition, triangular theorem and how to do that. The addition question which I did, A, B plus B, C, C, D, those questions were not given for certain years now. But those are in the syllabus because anybody can do no. So therefore they don't give now. Right. Now we'll come to another one, last one. A car travels towards east 100 kilometers and then it comes towards west 30 kilometers. Then find the displacement of the car. The displacement is with the direction distance. It is very simple. It went to AB, then BC. Then actual value is triangle is not there. AB plus BC. That is AC. Now CCM from A to C. Then altogether 100. So then AC is equal to AB minus BC. 100 minus 30. 70 kilometers. Then the displacement is from A to C. From A to C. That means the displacement is 70 kilometers towards east. This is east. This is how you do it. Here I consider displacement and did the question. Another one, then right. A car travels towards east 100 kilometers. Then it travels towards west 120 kilometers. Find the displacement of the car. Note down. A car travels towards east 100 kilometers, then travels towards west 120 kilometers. Find the displacement of the car. First one, anyhow it is AC, vector AC. Here vector AC, arrow should be there. Then first A to B 100. But B to C, it came 120. That means it came up to this point. Altogether 120 kilometers. Then vector AC we want to find. AC is equal to, or AC plus AB is equal to CB. AC means CA. If you want, you write CA. AC or CA. AC plus AB is equal to CB. So AC is equal to AB 100 is equal to 120. AC is equal to 120 minus 100. That is 20 kilometers. So then this part, 20 kilometers. AC means towards this direction. That is west. Then the answer is 20 kilometers towards west. That is the displacement. Note down. You write the displacement as 20 kilometers towards east. If you want to get more clearly, you can draw like this: AB one color, BZ, it's coming back to C. Red is the opposite one. Right. Now, another question. A car travels towards north 40 kilometers. A car travels towards north 40 kilometers. Then again, another 10 kilometers towards north. What is the displacement? A to B towards this 40 kilometers. Somebody stops there and then started. After that, towards the north, same up to C, 10 kilometers. So then AB plus vector AB plus vector BC. That is vector AC. So you have to find AC. AC is equal to normal AB value plus BC. So AB is 40, other one is then 50. So 50 kilometers towards north. A to C is 50 kilometers towards north. Right. That's all for the vectors. Sometimes we need the angle between vectors. At the moment, we are not doing it. The reason is trigonometry. You can see or go to next one. Now, that is trigonometry first part.